Alright guys, so here's what we got for ellipses. This is saying an ellipse is a set of points such that the sum of the distances from any point on the ellipse to two fixed points remains constant. These fixed points are called the foci of the ellipse. And then what we got here is, so we've got one focus, another focus, and so any point along here, no matter where it's at, so I could have like this point, and from here to here, that would be D1, and this would be D2. No matter what, they're going to be the same, no matter where the point is located along my ellipse. That's all it's saying. Okay? So the major axis is the longer axis of symmetry. The minor axis is the shorter, much better, axis of symmetry. The point at which the major and the minor axis intersect, that is our center. Okay? The vertices, those are going to be the endpoints of the major axis. And then our co-vertices are the endpoints. I guess this is always going to default back to a big fat color. Endpoints of the minor axis. Okay? So, right here on this one, this point right here is our vertex, this point right here is our vertex, this point right here is our co-vertex, this one right here is our co-vertex. Likewise here, co-vertex, co-vertex, and here is the vertex, and here's the vertex. We also have our foci right here, these little dots right here in the middle. Well, I shouldn't say in the middle, but they're inside the ellipse. Those are going to be our foci. Okay? So then what we have here is we have our vertices are plus or minus A units away from the center. The co-vertices are plus or minus B units away from the center. The length of the major axis is 2A, and the length of the minor axis is 2A. And the foci are plus or minus C units away from the center. And the formula to find C is going to be C squared equals A squared minus B squared. So all of this doesn't make a whole lot of sense until you really kind of put it all together. And then here's where you can recognize that right here. So I have this length right here. This is A. This length right here is also A. So if I have A plus A, that gets me the 2A right here. Okay? Likewise here, this point right here is B. And from here to here is also B. So B plus B is 2B. Oh, hey, look at that. Huh, I already made a mistake. We got 2B right here. Okay? All right. Now, if these, the foci, are plus or minus C units away, I've got C right here and another C right here. Okay? All of this is the same thing over here on this one. So we can clearly see here, this is 2C. This whole length here is 2A. And this whole length here is 2B. Okay? So now, looking here, we've got all of our standard form. So this one's going to be x squared over a squared plus y squared over b squared equals 1. And here I've got x squared over b squared plus y squared over a squared equals 1. Here I've got x minus h squared over a squared plus y minus k squared over b squared equals 1. And here I have x minus h squared over b squared plus y minus k squared over a squared equals 1. Okay, so if you look at these and compare, right here, this kind of makes sense that on this one, my A is horizontal. We know we also know that horizontal is our x coordinate. So if we look here, my larger number is underneath my x for both of these. My smaller number is underneath the y for both of these here, and that makes sense here because this is not as long right here as it is from vertex to vertex. Co-vertices are my smaller ones, so that makes sense. So your larger one is always going to be whatever the a value is, okay? So that's how you identify what your a value is whichever number is bigger. It's not always on the left. It's whichever number is bigger. Okay, so now with this one right here, all right, so right here you can clearly see there's no h, there's no k, so that means that we're centered at 0, 0. So I'm going to go ahead and mark that right here. Okay, so if I'm centered at 0, 0, I need to figure out what these represent. So remember in the other equation, I had x squared over a squared plus y squared over b squared, or x squared over b squared plus y squared over a squared. I just said a is always my larger, and that's going to be right here. And that's underneath my x. So right here, if this is a squared, I need to find my vertices, which are plus or minus a units away from my center. So I'm going to take the square root of 36, and that's going to give me 6. So that means I'm going to go 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6 units right and left. Because that's along my x, since this is underneath x. Then to find this one, I got square root of 16, so that's going to get me 4. So I'm going to go 1, 2, 3, 4, and 1, 2, 3, 4. Okay, so now I've got those. So let me go ahead and just identify the information that I have right here. My vertices, those are going to be located at 1, 2, 3, 4, 5, 6, plus or minus 6, 0. So I got positive 6, 0, and negative 6, 0. Okay. And my co-vertices, those are going to be at 0 plus or minus 4. Okay. I can go ahead and I can draw my little ellipse here. Mine look more squarish, diamondish. All right. So to find my foci, those are always along my major axis, so the longer one. So whichever one my vertices are on is the same axis that my foci are going to be on. Okay? So I got to go c squared equals a squared minus b squared, which is 36 minus 16, which gets me 20. So in order to get c, I have the square root of 20, which reduces the largest and only perfect square that is divisible out of 20 is the square root of 4 and the square root of 5. The square root of 4 is going to be a perfect square that I can reduce down to 2 square root of 5. So my foci are going to be at plus or minus 2 square root 5 and 0. I know that this number, I know that the 2 square root 5 is on the x. because that is the coordinate point that is changing along here. Every single coordinate point along here, my y coordinate is always going to be 0. It is on the axis. But every single x coordinate is going to be different. So I've got to know that it's going to be right there along that one. So what I'm going to do is I'm going to go ahead and put in my calculator 2 square root 5. And that gets me 4.47. Okay, so that means from my center right here, I'm going plus or minus 2 square root 5. So 1, 2, or I'm sorry, yeah, 3, 4, 4.47. And 1, 2, 3, 4, 4.47. So you can see right here, they're on my major axis, they're inside my ellipse, so I did good. Okay, let's try the next one. So this one right here, my center is also at 0, 0. I have no idea what I just hit. Okay. Center is at 0, 0. So I'm going to go ahead and mark that right here at my origin. And then I know that if I take the square root of both of these, this one's 3 and this one's 6. So this is my larger number, that's going to be my A. It's also underneath my Y. The last one was underneath my X. This one's underneath my Y. So that means I'm going up and down. I'm going 1, 2, 3, 4, 5, 6. So here's one. And 1, 2, 3, 4, 5, 6. So here's the other. And then from my X value, my B here, I'm going to be going horizontally 3. 1, 2, 3. And 1, 2, 3. Okay. Go ahead and draw. Nope. Go ahead and draw my ellipse as best as I can. I will repeat it until I'm blue in the face. I am not an artist. All right. So my vertices. Those are located at 0 plus or minus 6. My co-vertices are going to be at plus or minus 3 and 0. Now to find my foci, I just have to do c squared equals, always my bigger number, subtracting my smaller number, so 36 minus 9, which gets me 27. Which reduces here, if I take square root 27, I can reduce that to 3 square root 3, because 9 times 3 gets me 27. The square root of 9 is 3. Okay? So for my foci, those are always on whichever is my vertex one. So this is my vertex, my major axis, so it's always going to be on the same one as this one. This one is changing on my y, so I'm going to keep the x coordinate the same, and I'm going to go plus or minus 3 square root 3. So it's plus or minus my c away from my center. Okay. This recorder only lets me do 15 minutes before it cuts me off, so I'm going to finish this video and make another one.